So ants are adapted to living groups where individuals cooperate with one another in order to survive and reproduce. For example, they take care of their brood together, and they might even make a bridge out of their own bodies in order to reach a certain place. Indeed, if you throw a bunch of fruit flies or another solitary insect into an arena, you would see nothing much happening, but something different happens if you put the same number of female ant workers in an arena, and they will get together, form a group, and if this video ran for longer, you would see that they would start organizing themselves in a tightly high-functioning society, where they, for example, divide among themselves the tasks that they have to perform in the nest. The evolution of this complex social behavior in ants has relied on them forming stable groups in their evolutionary history, but perhaps surprisingly, we don't really know how ants decide to form groups. For example, which sensory information they use here to find each other and decide that these are the individuals that they should be sticking with. And so for my postdoc, I'm interested in the sensory and neural mechanisms that underlie group formation in ants. And so I've been using a combination of chemical analysis and behavioral assays to study the sensory cues that can induce aggregation in ants. And I found that group formation is a odor-guided mechanism, and that some long-chained hydrocarbons present on the skin of the ants or the cuticle can induce aggregation. And the ants are really attracted to these compounds so much that they smell with their antennae, and so much that if I apply a lot of these cuticular hydrocarbons in the form of a letter, they will start tracking it and form this quite unnatural shape. And in my poster, I have some other results that suggest that indeed these cuticular hydrocarbons are what the ants use to tell whether there's other ants around. For example, if I take a single young ant that would normally spend most of her time in the nest, and I put her in an arena where I applied some cuticular hydrocarbons, she will spend most of her time in there, as if thinking there's other ants. We team up with chemists to identify the specific compounds involved in this, and finally I have something about how we are setting up things to study how all this happens in the ant brain, where we put an ant on a ball where she can walk and exhibit some behavior while we record the brain activity, her brain activity. And I believe it's poster number 12. Yeah, thanks.
Wonderful, thank you very much. And